are discussing the module 6 of the organic chemical technology course, and in this we are discussing about the petroleum refining. The total 8 lectures are there in petroleum refining, and already we have discussed 3 lectures, and today I will be discussing about the thermal cracking, visbreaking and delayed coking. That is one of the very important operations that is being done in petroleum refining industry. This will be the coverage of the lecture: introduction, residue upgradation technology, cracking, thermal and catalytic cracking, where the brief about the process that will be given, not in detail about the catalytic cracking, cracking mechanism, development of the cracking processes, visbreaking and delayed coking, which is the now the most of the refinery they are using one of them, and so we will be discussing in more detail about the visbreaking and delayed coking. Another about the, because there has been a lot of the development in case of the thermal cracking processes. So, the fluid coking, flexi coking, UP uniflex process that has come, and so we will be discussing just brief introduction about these processes also. Let us come to the, already we have discussed about the distillation of the crude oil and the some introductory part of the petroleum refinery. So, as I discussed in the lecture 1 that we are having the two major processes in the refinery. One is the primary processes unit and the secondary process unit. In the primary process unit, what we are doing the crude distillation, crude oil distillation. And what is happening in case of the crude oil distillation? We are getting a number of the low value product which we cannot use as such, and so the just to increase their importance or the value, what we are doing, we are going for the secondary conversion process. So, what are the low value product from the primary processing, that is the low octane naphtha, which is not suitable, and so earlier it was going to the fertilizer plant, and the but now the, because most of the fertilizer plant they have shifted to natural gas. So, the naphtha, the low octane naphtha, especially the light naphtha that we are, that is going for further processing to improve the octane number, or some of the refinery they have gone for isomerization of low octane naphtha. Low value product others which we are getting from the atmospheric column and the vacuum column, also the vacuum distillation we are getting the light vacuum oil and the another stream of the high vacuum oil, the heavy vacuum oil. So, that has to be cracked further, that has to be processed to make it more value added. So, what are the secondary process we are using in refinery, that is the cracking of the heavy residue, that may be thermal or the your catalytic cracking, reforming of the low octane naphtha to gasoline, so that the octane number is increased, alkylation, isomerization, and desulfization is just to remove the sulfur compound, and sometimes the hydrodesulfization that is being done just to improve the impurity, so that the sulfur compound, nitrogen compound which are present there, that may not poison the catalyst. So, these are the some of the process. Let us now discuss about the thermal cracking. Why secondary process? Why we are going for the thermal or catalytic cracking or reforming? Just to upgrade the lower grade products, increase the value added products, maximize the production of the products in more demand, minimize the production of the low value product, because this is the earlier we started with the only thermal cracking. So, the huge amount of the product that was available which was not having, that was mostly used just like as a fuel oil, and so the just to minimize the production of the low value product, and as we know that we are more interested in the light distillate and middle distillate. So, our interest is to produce more and more light distillate and middle distillate which is being used in some or other form to meet the product and the environmental specifications, because you see the as I told you earlier also that the octane number requirement that is increasing. So, we will have to further process the low octane naphtha. Similarly, the environmental constraints are also there, our environmental standards are becoming more and more stringent. So, removal of the sulfur, that is important. So, that is the requirement to give the more value added product to meet the requirement of the from the environment point of view. So, some of the secondary process that is being done in we are having in the refinery. Now, let us come to the thermal chemical. With the continuous depletion in the world oil reserve and increasing demand of the petroleum products, the refiners are forced to process more and more heavy crude, because I discussed earlier also that the now we are left with the more heavy crude, opportunity crude, and we will have to process this. So, the importance of the bottom of barrel conversion gain importance, especially with the availability of more heavier crude oil and the opportunity crude oil. The cost of advantage of the heavy crudes over light crude has incentivized the many Indian refineries to process heavier crude. Therefore, because the what is the cost of the heavier crude is much cheaper than the light crude or the your sweet crude. So, therefore, increasing the heavy residue produced at a time when fuel oil demand is declining. So, this is the reason why we are going for more and more heavy crude oil. In order to dovetail both the requirement of processing crude oil of deteriorating quality and enhancing the distillates of the improved quality, technological upgradation have been carried out at refinery, which takes care of the processing heavy crudes as well as the maximizing the value added products and stringent product quality requirement. Let us now discuss the cracking. Cracking means the, as you know, cracking of heavy residue. What we are in refinery, the term that the cracking of the heavy residue is most to the lighter product. So, the cracking of the heavy residue is most commonly used method for upgradation of the residue, which are low value product in the refinery. This involves the decomposition of the heavy residue by exposure to extreme temperature in the presence or absence of the catalyst. So, some of the thermal cracking processes are there where we do not use the catalyst, but other process that has been developed where the advantage, because that will be discussing in the next lecture about the when we will be discussing about the FCC, the in presence of the catalyst we are doing the cracking. Thermal cracking. Cracking at elevated temperature in the absence of catalyst. These are the some of the actually the processes that is being used in refinery: Visbreaking, delayed coking, fluid coking. These are the some of the process, thermal cracking process. Catalytic cracking, cracking in presence of catalytic, fluid catalytic cracking, hydrocracking, deep catalytic cracking. So, these are the some of the technology, and another some of the technology that has been developed by the Indian Oil Corporation also, the catalytic cracking process, that I will be discussing while discussing the catalytic cracking. What are the residue upgradation technology? Thermal cracking, already I told you the Visbreaking and delayed cooking, that is one of the very commonly used process in refinery. Fluid coking and flexi coking process that has been also developed to improve the thermal cracking processes, EOP Uniflex TM process, deep catalytic cracking and the IOCL Indomox technology, that is actually coming in the part of the catalytic cracking. So, in the catalytic cracking, fluid catalytic cracking and the hydrocracking. So, the cracking mechanism. So, whatever the cracking reaction that is taking place, that is the free radical mechanism there, initiation, propagation and the termination. So, these are the steps that is taking place during the cracking process. Initiation, this is the reaction that is taking place in the initiation, and the lighter product we are getting, and again from the propagation this is converted to many other large number of the product, and finally the termination where we are getting some of the lower molecular weight hydrocarbons. Now let us come to the thermal cracking. Thermal cracking process is used for upgradation of heavy residue of refinery since long and still being used, because you see with the coming of the more and more heavier crude, now thermal cracking using the Visbreaking or the delayed cooking, that has become important operation in the refinery. Because in the what is happening in the various processes like the crude oil distillation, or even in case of the cracking process also catalytic cracking, we are producing the heavy residue. So, that can be further that has to be cracked to more value added products, and that is the reason why the importance of the Visbreaker or the delayed coking is there. Although the petroleum coke was first made by northwestern Pennsylvania in the 1860s using cracking. However, a real breakthrough in the thermal cracking process was the development of the first cracker by William Broughton and the first use in 1913. Thermal cracking. Heavy residue are a mixture of molecules consisting of an oil phase and asphaltene base in physical equilibrium with each other in colloidal form. The asphaltenes are high molecular weight, relatively high atomicity molecules containing high level of the metals. During the thermal cracking, the long molecules thus depleting the oil phase in the residue. At a certain condition, asphaltenes is distributed and asphaltenes precipitate. At this stage of conversion, the product residue becomes unstable. Thermal cracking reaction. Cracking of the side chains free aromatic group, dehydrogenation of naphthenes to form aromatics, condensation of aliphatics to form aromatics, condensation of the aromatics to form higher aromatics, and dimerization or the aromatization process. These are the some of the reaction that is taking place, and one of the problem in case of the formation of the coke during the process, which is the unavoidable process in case of the thermal cracking or even in the catalytic cracking, where the high temperature that is there. This is the development of the cracking processes: 1860 thermal cracking, 1910 batch thermal cracking, 1912 that is bond cracking, and the 1914 to 1922 that was the continuous cracking process that was developed. In case of the thermal cracking, what are the process variables? Feedstock property, because that will play important role on the what type of the product that we are going to get after the cracking. Cracking temperature, residence time, pressure. Thermal cracking, that may be medium, high, ultra. Cracking with ultra high cracking means the cracking with high temperature with very short residence time, because the residence time that is playing very important role in the cracking processes in the formation of the coke. Now, let us discuss some of the important thermal cracking process and the process condition, then we will go in detail about the individual process. This is the condition we are using in case of the Visbreaking, mild thermal cracking, low severity, temperature is 470 to 500 centigrade at 50 to 200 psig, improve the viscosity of the fluid, low conversion, residence time 1 to 3 minutes, heated coil or drum that we are using. Delayed cooking operates in semi batch mode, moderate temperature, heating at 90 psig, soak drums are used, cooked until the solid that is separated, they are cooked, removed hydraulically 20 to 40% on feed, yield is 30 to 20 to 40% at temperature 430 degree centigrade, the yield slightly go higher 30%. This is the 30% is that particular temperature. Fluid cooking, we are having the severe higher temperature, severe condition, and so 500 to 520 oil contained the refractory coke, fluidized bed we are using with the steam even heating, higher yield of the light ends, less coke yield is there in this process. Let us now discuss the Visbreaking process, the detail of the Visbreaking, because this is one of the important unit in refinery, as I told you earlier also. Visbreaking is essentially a mild thermal cracking operation at mild condition, wherein long chain molecules in heavy feedstocks are broken into short molecules, thereby leading to a viscosity reduction of the feedstock. So, this is the what is happening, how we are getting the lighter products, and because the lighter products will be less viscous. So, now all the new Visbreaker units are of the soaker type, because the soaker drum that has been provided with the base coil cracking, where the Visbreaker with the coming of the soak drum, we are giving the additional reaction that is taking place in the soaker drum, and so the it is avoiding the formation of more and more coke. Soaker drum utilizes a soaker drum in conjunction with a fire heater to achieve the conversion. So, higher conversion is there, less coke formation is there. It reduces the viscosity and the pour point of the heavy petroleum fraction, so that the product can be sold as a fuel oil. It gives 80 to 85% yield of fuel oil and balance recovered as light and middle distillate. So, the again still the major portion is fuel oil, and rest is because in all the Visbreaking process or the delayed cooking, we are getting the light and middle stage, and again the sum of the heavier fraction. Product which we are getting from the Visbreaking: gas, naphtha, heavy naphtha, Visbreaker gas oil, Visbreaker fuel oil, and the mixture of Visbreaker gas oil and the Visbreaker tar. Conversion can be achieved by two ways: high temperature, low residence time cracking, that is the coil Visbreaking we are doing; low temperature, high residence time cracking, soaker Visbreaking. In both the cases, our objective is just to break the heavier fraction into lighter fraction. Only the changing the residence time and the temperature, the type of the product which you are getting, that will vary. The reaction involved, these are the reaction that is taking place in case of the Visbreaking. The reaction in the cracking process, I told you it is very complex in nature, and depending upon the operating condition, temperature, pressure, type of feedstock, the product which you are getting after the Visbreaking, and that will vary. Soaker Visbreaking process. The furnace operates at a lower outer temperature. A soaker drum is provided at the outlet of the furnace to give adequate residence time to obtain the desired conversion while producing a stable residue product. The products from the soaker drum are quenched and distilled in the downstream fractionator. Feed to the soaker are atmospheric residue to get gasoline and diesel oil, vacuum residue to reduce the viscosity. So, the depending upon the feed which you are using in case of the Visbreaker, the type of the product which you are getting, that will vary. Reaction, these are the reaction already we have discussed: separating, aluminization, cyclization of the naphthenes, condensation of the cyclic molecules. So, the different reactions are taking place. Advantage of the why we are having the soaking drum in the Visbreaker, that is the furnace operation at a lower temperature, 50% reduction in the fuel oil, less coke tendency, which I told you that because we are giving more reaction time at a lower temperature in the soaker drum, larger running time between two decooking operation, coke deposit rate 3 to 4 times slower than in conventional units, better selectivity towards gas and gasoline productivity. These are the Visbreaking condition, again that will vary with the your type of the feedstock you are processing. This is the temperature with the soaking drum if you are using. Soaker Visbreaking process, The products which we are getting from this is gas, naphtha, gas oil and furnace oil. The composition which will depend upon the type of the feedstock process, which actually depending upon the feedstock, the whole product range which we are getting after the cracking, that will vary. A typical yield pattern may be gas 1 to 2%, naphtha 2 to 3%, gas oil 5 to 10%, furnace oil that is 90 to 92%. Visbreaking furnace, in the furnace we are having the convection zone, that is the top, to increase the thermal efficiency, radiation zone, bottom tubes where the actually the cracking is taking place, average heat flow, this is for a particular case 20 to 30 kilowatt per meter square. Variables in case of the soaker visbreaking process. What are the variables? Feed rate, furnace transfer temperature, visbreaker torque winch to transfer line, fractionation pressure, fractionation top temperature, circulation reflux ratio. Visbreaker torque winch to fractionator bottom, visbreaker torque winch to visbreaker torque steeper bottom, stabilizer temperature and pressure. These are the some of the operating variables in case of the visbreaking. This is the flow diagram, a typical visbreaker which is not having any soaker. So, the feed that will go to the preheater, from the preheater to it will go to the furnace where the cracking that will take place, and then the cracked product that will go to the separator, from the separator the product, the heavier part that will be getting as a residue, and the lighter product that will go for further fractionation of the lighter and middle distillate and the heavier residue. So, this is the separation of the gas, gasoline, visbreaker, that is the distillate, middle distillate that will be getting, here is steam that is. So, here it may be the light distillate, middle distillate that will be getting, and then the visbreaker residue finally will be getting. These are the product that is you will getting after the fractionation of the product which we are getting from the after the cracking from the furnace. Now, let us discuss the visbreaker with the soaker, because slightly difference in the here we are providing a soaker. The purpose of the soaker is to give the more residence time here, and the reduced temperature is there as I discussed earlier. The feed is going to the preheater, preheater to furnace, and from the furnace it is going to the soaker, and from the soaker again rest of the process that is same, because the product again from the soaker, here actually we are giving more residence time for the reaction, and after the soaker the product that is going to the separator, from the separator again as I told you, the residue which we are getting, that is the visbreaker residue, and these are the some middle distillates, gas, gasoline and steam that you are of course that you are adding here. Now, the actually the coil visbreaker which without soaker, the coil visbreaker process, the desired cracking is achieved in the furnace at high temperature, and the products of cracking are quenched and distilled in downstream process. Here no soaker is provided, directly whatever the cracking reaction is taking place, that is taking place in the furnace. One of the important problem in case of the furnaces, that is the coke formation, which is reducing the efficiency of the furnace, and sometimes the higher pressure drop, the higher fuel consumption that is resulting. So, frequently you have to clean depending upon the type of the crude oil, the residue which you are getting from the crude oil. Advancing the visbreaker coil heater design now allows for the isolation of one or more heater passes for decoking, because decoking is the removal of the coke during the process, which is because the coke coke formation will be always there. Only you can reduce the amount of the coke that is formed, eliminating the need for this shutdown and the entire visbreaker down for the furnace decoking. Integration of the coil Visbreaker with vacuum units is also being considered in many areas of the world, because the vacuum residue that will go to the coil Visbreaker, and the breaking or the cracking that will take place. So, this is another development in coking. Now, we have discussed about the Visbreaking, because you see the name itself. In one process we are telling it the Visbreaking means the reduction in the viscosity. Another process which we are using for the processing of the heavy residue is the coking process. Coking is very severe form of thermal cracking and converts the heaviest low value residue to valuable distillates and petroleum coke. So, this is the actually the process where we are getting a petroleum coke, which I discuss also while discussing the raw material and the gasification part. Petro coke gasification, now some of the refinery, just like Jamnagar refinery, where they are processing more and more heavy residue, they are going for the petro coke gasification, and that is just for the generation of the hydrogen through the partial oxidation or the gasification process. Relatively severe cracking operation to convert residual oil products and represent the complete conversion of the petroleum residue to coke and lighter product, because the residue which you are getting here coke and the lighter products you are getting. So, coke again because many of the cement plant they are using this petro coke as their fuel. Various type of the coking process are delayed coking, fluid coking or the flexi coking. Mechanism of the coke formation. The colloidal suspension of the aspartame and the resin compounds is distorted, resulting in the precipitating of highly cross-linked structure of the amorphous coke. The compounds are also subjected to cleavage of the aliphatic groups. The process involves thermal conversion of vacuum residue or other hydrocarbon residue, resulting in these are the products: fuel gas, LPG, naphtha, which called the cracked naphtha, gas oil and coke, and essentially a complete rejection of the metals. Various types of the coking process, already I told you, we are having the delayed coking, fluid coking and the flexi coking. Now, let us discuss in more detail about the delayed coking. Delayed coking process is used to crack heavy oils into more valuable light liquid products with less valuable gas and solid coke as byproduct. Although the first delayed coking plant was built in 1930, however, delayed coking process has been evolving for the last 78 years. The past few years have been changes in feedstock and has major impact on the design and operation of the delayed coking. Delayed coking consists of the thermal cracking of the heavy residue in empty drum where deposition of the coke takes place. Feed to the delayed cooking, which normally we are using vacuum residue, which we are getting from the vacuum distillation column, FCG fluid catalytic cracking residue or the cracked residue. Studies show that the feedstock quality and severity on the conversion impact the stability of the Visbreaker residue. Product here we are getting in case of the delayed cooking are the gases, naphtha, fuel oil, gas oil and the coke. So, already I told you in case of the Visbreaking or the here also in case of the delayed cooking, the product yield and the quality depends on the type of the feedstock being processed, because all the product yield totally that will depend upon the more heavier, then the whatever the products will be getting, that will be different in quality than what we are if we are cracking some of the lighter residue. So, typical delayed cooking consists of a furnace to preheat the feed, coking drum where the fractionation of the product takes place, separation, not the fractionation exactly, it is the separation of the products takes place and the coke is separated from the reaction pod. The reaction involved in delayed coking is partial vaporization and partial cracking, cracking of two vapor phase in the coke drum and successive cracking use polymerization of liquid phase resulting in the formation, because always the formation of the coke is because of the polymerization reaction that is taking place in any furnace or any process. This is about the delayed coking. Here the feed is going to the coking furnace, the temperature is raised here and then it is going to the coking drums, and from the coking drums it is going to the fractionator. Again from the fractionator we are getting the different products, the gas, coker gasoline that may be there, coker gas oil we are getting, and the residue from the fractionator and from the coking process. So, that will be the residue that we will be getting. Operating variables in case of the delivery. The operating variables are characterization factor. Already we discussed the how the characterization factor you can just the whether the is paraffinic, naphthenic or the intermediate base, degree of reduction, Konradsen carbon, sulfur content, metallic constituent, low feedstock, characterization factor and high carbon residue, increase coke yield and quality of gas oil and endpoint. Operating variables, as I told you in case of the any furnace, the temperature that is one of the very important variable. So, various operating variables in delayed coking are temperature, pressure, recycle ratio, transfer temperature and coke chamber pressure. These are the major variables in case of the delayed coking. Now, let us discuss about the effect of the some of the important variables which are happening in case of the delayed coking. Higher temperature results in more vaporization of the inlet material causing low coke yield. High temperature results in hard coke while the coke is softened when too low temperature is maintained. So, the coke quality also, because the whatever the petro coke we are getting from the refinery, that is also varying in the properties depending upon the process also, because the coke quality which we are getting from the catalytic cracking is different than the what we are getting from the Visbreaking or the delayed coking. Higher pressure result in an increase in the coke and gas yield, which is undesirable, as basic objective is to improve the yield of distillation with less coke formation. Because coke is not our, to make coke is not a main objective. Our objective is to get the more light middle distillate or some of the more value added product. Now, let us discuss about the some other development which is taking place in the thermal cracking process, that is the fluid coking process. Fluid coking is non-catalytic fluidized bed process where residue is cooked by spraying into a fluidized bed of hot fine coke particles. Here we are using the fluidization phenomena for the cracking process, and so definitely, as you know, in case of the fluidization, definitely the improvement in the quality of the product is there, and similarly other parameters are also getting affected, better operation is there. So, higher temperature with shorter contact time than the delayed coking results in increased light and medium hydrocarbons with less coke generation. Shorter residence time can yield higher quantity of liquid, less coke, but the product have lower value. So, we will have to provide the optimum residence time. Another development that has been in case of the cooking process, that is the flaxy coking. It is continuous process which involves the thermal cracking in a bed fluidized coke and gasification of the coke produced at 870 degrees centigrade. So, this is the flaxy coking. Again the UOP, because you see the we are using more and more heavier crude. So, there has been continuous development in the thermal cracking process also. So, the UOP Uniflex TM process, which is now available. So, it is high conversion commercially proven technology that process low quality residue stream like vacuum residue to make very high quality distillate products. So, this was about the thermal cracking process which we are using in the refinery and the, but you see the all the refinery they are having both the catalytic cracking and the thermal cracking, because some of the during the catalytic cracking process also, it may be FCC or the hydro cracking, we are producing some heavy residue and which is further cracked along with the residue which we are getting from the vacuum distillation column. So, in the next lecture we will be discussing about the catalytic cracking, and where the two major processes that we will be discussing, that is the fluid catalytic cracking and the hydrocracking. So, these are the two processes that has become integral part of the refinery, we will be discussing in detail. Only in case of the thermal cracking, because all the refinery along with the catalytic cracking they are also having the thermal cracking, because now we are processing more and more heavier crude, and so because of that the generation of the heavy residue is more, and so the processing of the heavy residue to get more value added product through the middle distillate or the even some other fuel oil product. So, that has become very important.